This video will show you how to calculate using the concept of the mole. If you remember from class, the mole is our counting unit that we use in chemistry. It's just like the counting unit of a dozen. So in chemistry, a mole is equal to 6.022 times 10 to the 23rd atoms or particles or molecules, whatever it is that we're talking about. The mole is a central concept in being able to relate atoms or molecules to the mass of a substance. Remember, we can measure the mass of a substance in the lab, but we are unable to calculate or measure the atoms or molecules in the lab. So the mole provides the way that we can relate those two concepts. A brief review, remember that to relate the mole to the mass, that's where we are using the molar mass. That's the mass that's found on the periodic table. To relate moles to atoms or molecules, that's where we're using Avogadro's number, 6.022 times 10 to the 23rd. It's helpful at times to have this map or pathway in front of you to help you plan out the problems that you're going to solve. In this video, I'll be doing several problems, one from each type of problem you may be asked to solve for. You can fast forward through any that you don't need or go back and review any that you are having problems with. The first problem we'll do is converting grams to moles. Let's say we had 64.1 grams of aluminum and we want to know how many moles of aluminum that is. We start out by writing our given piece of information in parentheses, 64.1 grams of aluminum, and we're trying to convert it to moles. So mole of aluminum needs to be on top. I go to the periodic table to find the molar mass of aluminum. And depending on what periodic table you have, you'll have something similar to this, 26.9815 grams. Notice that the grams will cancel out. And when I pick up my calculator and type in my answer, I need to round to 3 significant figures. Remember, my significant figures are based on my given piece of information and not the information that is in the conversion factor. So when I type this into my calculator and round to the proper number of sig figs, I get 2.38 moles of aluminum. And that's how you convert grams to moles, by using the molar mass. If I do the opposite problem, converting moles to grams, I'm still going to use the molar mass from the periodic table, so don't put the periodic table away just yet. 1.22 moles of sodium, and I'm trying to figure out how many grams that would be if I were to go into the lab and measure that out. So in this case, I want moles to cancel out, so mole needs to be in the denominator of my conversion factor. I go to my periodic table and I find the molar mass of sodium, which is 22.99 grams. Moles cancels out. Pick up my calculator, and I need my answer to be in 3 significant figures, and I should get an answer of 28.0 grams of sodium. Notice that the molar mass is in the same place. I mean, it's used as a conversion factor. It's just in the numerator in this case and in the denominator in their previous example. The third type of problem you'll be asked to solve is converting atoms to moles. Remember, the number of atoms is a huge number, and so to make it more manageable, we think of it in our counting unit of moles. So our example here has 3.01 times 10 to the 23rd atoms of rubidium, and we want to figure out how many moles that is. Well, regardless if we're talking about atoms or molecules or shoes or birds, Avogadro's number is going to be the same. So this middle step, the conversion step, will always be the same. 1 mole of anything, notice I don't even have to put a label here, 1 mole of anything contains 6.022 times 10 to the 23rd. In this case, it would be atoms. Atoms cancel out. My answer is going to need 3 significant figures. So when I multiply this across and divide by Avogadro's number, I get a nice even number of 0.500 moles of rubidium. Remember, the zeros here are important because they add to the significance or the level of precision to that answer. If I were to go in the opposite direction and convert moles into atoms, we're still going to use Avogadro's number, just in a different location in our conversion factor. So in this problem, I'm asking you to convert moles into atoms. 1.004 moles of bismuth. And I want to convert that into atoms. So in this case, the mole will be in the denominator, and Avogadro's number will be in the numerator, 6.022 times 10 to the 23rd atoms. Moles cancels out. I'm left with atoms, so now I can multiply across. 1.004 times Avogadro's number gives you an answer of 6.046 times 10 to the 23rd atoms of bismuth. Notice I need 4 significant figures because my starting amount had 4 significant figures. So we've done all of the one-step problems, so let's move on into the two-step problems. Recall here, when we're talking about two-step problems, we're either going from mass over to atoms, or perhaps from atoms over to mass, and we have to go through the mole. So that will be a two-step conversion from atoms to moles, and then from moles to mass, or vice versa. So let's try example 5, converting grams to atoms. Again, this will be a two-step conversion. If I had 54.0 grams of aluminum, and I want to know atoms, I must first convert grams of aluminum into moles of aluminum. So 1 mole of aluminum. I go to my periodic table to find the molar mass is 26.98153 grams. Grams cancels out, and I'm left with moles of aluminum. But don't pick up your calculator until you do all your conversions. It prevents you from making calculation errors along the way. So now we want to do our second conversion from moles into atoms. Remember, 1 mole of anything contains 6.022 times 10 to the 23rd particles. In this case, we're talking about atoms. Moles cancels out. I'm left with atoms, so that means I can pick up my calculator. 54.0 divided by 26.98153 multiplied by Avogadro's number. And the answer on my calculator, I need to round to 3 significant figures. And so I get an answer of 1.21 times 10 to the 24th atoms of aluminum. This is a two-step conversion. I'm going grams to moles, moles to atoms. The mole is the central concept. We'll do one more example where I'm converting atoms into grams, which is the opposite of the problem that I just did. So here I'm starting with atoms of tantalum, and I'm trying to convert to grams of tantalum. So my starting amount is 6.022 times 10 to the 24th atoms of tantalum. So to go from atoms to grams, I must first convert atoms into moles. 1 mole of anything contains 6.022 times 10 to the 23rd atoms. Atoms will cancel out. That's how I know how to set up my conversion factors. In my last step, I want to convert moles into grams. This is where I pick up my periodic table. So 1 mole of tantalum, the symbol is capital Ta. 1 mole of tantalum has a molar mass of 180.9479 grams. Moles cancels out. I'm left with grams of tantalum. So I want to take my starting amount divided by Avogadro's number and then multiplied by the molar mass. And when I do that, I want my answer to have 4 significant figures. So when I round my answer from my calculator, I get 1,809 grams of tantalum. If you're not getting this answer, or your answer has some weird exponent, remember, to prevent any kind of weird calculation errors, put values that contain exponents in parentheses on your calculator. Oftentimes your calculator is performing the calculations in the wrong order, or the order that you don't want them to do. So if you were to put those 2 values into scientific notation in parentheses, that should prevent any calculation errors. Again, if you are still having problems after using parentheses, then make sure you bring your calculator to class. All of these problems have dealt with atoms. If we were to be asked to deal with compounds or molecules, we solve them in the exact same way, except you need to find the total mass of the substance, as shown here with finding the molar mass of methane. I find the mass of one carbon, and I add it to 4 hydrogens, and so the molar mass would be 16.04246 grams. The problems are still solved the same way. It's just a matter of finding the total molar mass for that substance.